Okay, for 25, we want to see if this geometric series is convergent or divergent, and it's only convergent if the absolute value of the ratio, so the thing that's being raised to a power, is less than 1. Because as we're adding these terms infinitely, we want these terms to essentially be 0 when n gets really large, right? Because if you're just adding what amounts to 0, the total sum is not going to change. And that's only possible if this ratio is less than 1. So if you take, say, 1/2, you raise it to 1,000,000, that's going to be practically 0. Whereas if you take any absolute value greater than 1 and you raise it to a very large power, that's just going to grow. It's just going to grow without bounds. So what we're going to do here is we are going to write this out, but we're going to have to adjust the index. So 0 to infinity of pi to the power of n over 3 to the power of n plus 1. So right now we can't evaluate it because we don't have a r to the power of n, since these are indexed differently, right? So we need to get them to the same index, and what we're going to do here is we're just going to, this 3n plus 1, we're just going to break this down as 3 to the power of n times 3. Because if we break it down, 3 to the power of 1, right? It's the same thing. So we're going to rewrite this as the sum from 0 to infinity. Oops, my infinity was very ugly. Okay, of pi to the power of n over, I'm just going to put this 3 to the power of 1 in front. And now I'm going to rewrite this so that I can get a single number to the power of n. Oops, that is not what I meant to do. Okay, and I'm just going to rewrite this as infinity. So I'm going to break this down into first 1 times 3, and then times pi over 3 to the power of n. So that is my geometric series. It now does look like it is in this format here. And we can see here that our a is going to be 1/3 because that's a constant, and our ratio is going to be pi over 3. Now the absolute value of pi over 3 is greater than 1, so what this means is that if you take this and you raise it to a very large power, it's just going to be a very large number. So we're going to keep adding large numbers, and that sum is not going to converge. So it diverges. And that is it for problem 25.